In this video, we're going to take a look at the 2006 SOL release test and all the problems on that. Now, I will say that the SOL frequently starts right off the bat with the hardest problems, which are rational and radical. So rational being fractions with variables and radical being roots with variables and numbers. So let's just look at the very first question, and it's kind of interesting. In my opinion, it might be one of the hardest on the entire test. It's kind of funny. And the reason it's like that is you actually need to rewrite anything that's not alphabetized. So you rewrite this to negative d squared plus 9, which if you don't know that little trick, you're kind of already, in trouble. And then both of these, because they have a negative lead coefficient, you're going to factor out that negative to start off. So negative will make this term positive, this one negative, and this one negative. And then if I take this negative out, I have a positive and a negative. And this very easily factors into d plus 3, d minus 3. But this thing, you have to use your technique, whatever it is. I like the box method. So I use 2d times d is 2d squared. The 15 is 3 times 5. So I put a 3 and 5 here and arranged it so that I could get a subtraction that'll give me negative 1. So 5 minus 6 is negative 1. And those two come out to negative 15. So my factors are along this and this part of the box. So I factored it out with 2d plus 5 and d minus 3. And then this part also had to be factored, but luckily the SOL did give us a bit of a break here, because if I go back to this factorization, if I add those, I get 11. So I just changed that factor to a plus 3. And then I start canceling after I realize that I have to keep change flip. So I keep this, that's why that didn't change. And then I change that to multiplication, and then I flip this over. You can see I did it here. And then I would write everything down as a factor. Then I can cancel that d plus 3, cancel the negatives. I'm left with 2d plus 5, which is 2d squared, 2d plus 5 squared, divided by 4d plus 1. Now, there is an awesome way to check this on the SOL if you realize that Desmos will graph anything, including, this problem. And so to check if you're right, if you type in negative 2, and you can't use d, as you can see, I'll give you a workaround. So if you type this in, the first thing you have to realize is that it screams at you and says can't use d. So whatever variable they give you use an x instead. So I use an x, and I divide this, and then I put in 9 minus x squared. And watch this, this is important. I come over here and I try to put a division symbol, and it puts it in this format, which I commonly call the tower of math rather than division. It is division, because when you look at it, it looks like a huge tower of math, which is kind of funny. But keep in mind that Desmos only understands it that way. It doesn't understand the little division symbol you learned in elementary school. So I type it in. I make sure I didn't make any typos. It's very frustrating to check a problem that you made a typo on, because you'll never get it right. And then you get the graph by zooming in and out. Okay, so there is my graph. I'm going to make it a different color. All right, and then you can check your answer by simply typing it in below. And if you see only one graph, that means they have the exact inputs and outputs, making them equivalent answers. So if I type in my answer of this, and then I divide it by 4x plus 1, of course, I accidentally typed a d. So you put an x there. Now watch, I did that on purpose so you could see it. So blue graph, boom, right over top of it, this graph. I'll make it red so it stands out a little more. So it's kind of cool how powerful that is. And again, let's say you thought it was a -1. The reason you know it's not -1 is because, oh, look, there's two graphs. Now, you might have to zoom in. Oh, it's very clear if I zoom in that there are two graphs, right? So with the correct answer, I do, in fact, have one graph. And you can use that on any problem on the SOL that asks you to simplify or reduce or factor if there's one variable. All right, so I come over here and I have a very similar problem, but this one's addition, but there's a little bit of a block to the thing, and I'll show you. It's kind of interesting. Let's go over how to do it. So x plus 7, x minus 7 is here, and you have x minus 4. That's the LCD. Sometimes the SOL just asks for the LCD. And then you multiply by what's missing. So this doesn't have the -4. You can see it over here. It's missing that. This one is missing the plus 7. You distribute. It starts out really nicely. Then you distribute this and distribute that, and then distribute the negative sign. That's very important, because a lot of kids will think that's a plus 21 when it's a minus 21. You combine like terms, and you're like, sweet, I got my answer, right? Notice carefully that the denominator doesn't have the right amount of stuff, right? So if you type this in, it's actually not this one. And the reason it isn't is because you have to factor this. And I factored it with the box method. That's my preferred way. So 2x squared would be 2x times x. That gives me 2x squared. 21 is 3 and 7. And then I have to arrange it in a way that I subtract, because that minus says to subtract to get negative 11. So I made the 14 negative, and when I added it right here, or subtracted it, however you want to think about it, I get negative 11 there. And then I just carry that negative through, giving me 2x plus 3, x minus 7. This will cancel, giving me my answer. And again, if you graph this problem and graph that answer, you will have one graph and it will be correct. But imagine if they would have put the proper denominator here, and then both will work. If that happens, the answer that is correct is always the one that's the smallest reduced function. If you ever get two that are correct, the answer is the smallest reduced function. All right, so then they do another one here, which is actually, in my opinion, the easier of all of them, as long as you remember the rewriting thing, right? You have to rewrite this to be d minus 13 and rewrite this as negative d plus 13. Then you keep change flip. So I kept this. I changed it to multiplication. I flipped this. Then I need to factor out my GCF of -1, and then that'll cancel. And then, of course, you can cancel a little bit in here with the 6 and the 4 and the d and the 9, and you can find your answer. And you can still graph it. You can still take this and graph the correct answer. And then we move into the world of roots. Roots cannot be checked on Desmos because there are two variables. So you have to do this problem longhand with this one exception. The first thing you start doing is try to take the number separately. So you take the 6th root of 729, and you can type that in and get a little bit of a respite here, because if this is an integer, you're done. So you know immediately that like none of these are correct, because you are permitted to type the number in. Now, if that number is a decimal, you have to make a factor tree, which will be the next example. So the first answer the SOL gives you is to simply turn this thing into a fraction, knowing that the root is the denominator and the exponent is the numerator. So that's my first answer, 17/6 and 11/6. But then the second answer is to then actually divide this out. So if I divide the denominator into the numerator, it goes in there twice, which means there's 2 q's outside. You can see that here. And then the remainder is 5, meaning there's 5 q's inside. Same thing with the r. 6 goes into 11 once. I have 1 outside, remainder of 5 inside. And so it ends up coming out with both those answers. There are a lot of roots. Make sure you know how to do them, and make sure you understand that if there are two variables, that whole Desmos graphing thing is, you can't use it. The very next question is another one of these. And what ends up happening is if I try to put this into Desmos, okay, so if I come in here and I start off by doing the cube root, which is found under function miscellaneous in root, so the cube root of 576, I get a decimal, which means I got to do the whole tree, right? And so once I do the whole tree, I then have to do this one, which would be 8/3 and 27/3. And then I notice they don't give me any of those, but I can at least, get rid of a couple because of, things that you don't see. So in this one, you're going to have to do this whole tree, find the correct root. You're going to have to divide 3 into 8. 3 goes into 8 twice. So it has 2 outside the root and 2 inside the root. Same thing with this one, but this one reduces, so you're already done. And that's how I already eliminated these, because 27 divided by 3 is 9, so it had to be A or D. And now you can kind of see this one. I actually do the letters first because they're a little easier than making this huge tree. And if you make the whole huge tree, you'll get the right answer. All right, so then we come to the factoring cube method. Notice this one, can't use Desmos, 2 variables. This one, 1 variable, I can use Desmos to check my answer. So this one is the a plus b, a squared minus ab plus b squared rule. It is the only rule you must know on the SOL. Everything else is on the formula sheet. This one you have to know. So a is to multiply 5m 3 times. B is to multiply 7 3 times. The negative is taken care of in an acronym called SOAP, which I'll explain. So the 5m, you write down 3 times. 5m, 5m, 5n. Don't forget to square this because the formula has a square. The 7, you do the same thing from the right to the left. So 7, 7, and 7. Make sure you square that. And then the SOAP works like this. Same as the original problem, minus. Opposite of the original problem, plus. Always positive last term. Then square these, and you have your answer. Now, you have really got to be careful with the Desmos check thing about zooming. Watch this. It's very interesting. If I type this in, again, I can't use the M. So if I use the M here, it'll yell at me and say, don't use M, so change it to X. And then I type in my answer. Okay, you can't see the graph because you got to zoom out. Okay, so there's my graph. And I type in my answer, 5x minus 7. And then I type in 25x squared plus 35x, and then plus 49, and of course you get one graph. Watch this. If I type in C, which is almost exactly the same, but they put a 70 here, it looks like the same graph too. You've got to zoom in, right? If I zoom in, keep zooming, there are clearly two graphs now. So just be careful. If I put in the right answer, even when I zoom in, there'll only be one. So I'm going to put in 35 and then boom, one graph. Be careful about using that. I would use it as a check. If you try to use it as a replacement for work, your SQL is not going to turn out as well as it would if you did the work and then checked it. If you do the work and check it, you're going to do very, very, very well. Okay, so then we have a solution problem, which you just reverse the order of operations on. So I'll do that. Just to remind you, this process is the same for absolute value as it is for roots, for all of them. So you subtract 6, no big deal. Okay, because it's at the bottom of the order of operations to add or subtract outside of the grouping symbol. And then that is not a cube root, that's a 3, so be careful with that whole thing. Then here we have -3, and then we divide because the next thing on the order of operations is to multiply or divide, so I divide by 3. If that were a cube root, I would have to have moved to the exponent step. And then here we get -1. Okay, then we square both sides to get rid of the square root. If it were a cube, I would cube both sides, no big deal. And then here I get 2x minus 4 equals 1. Then I have to add 4, okay, and then I divide by 2 and I get 5/2. But 5/2 is extraneous. Because if I put 5/2 back into here, it's a square root of a negative. So make sure you're checking your stuff, right? I mean, isn't that frustrating to get all the way to the end there and not check it? So if I type in 3, and then I type in the square root of 2x, I can do this two ways. Probably the easiest way is to just put the 5/2 in here in a parentheses as your answer, because it does a nice job with that. And then -4, make sure that -4 is still inside there. And then plus 6, it says it's 9 because it's extraneous. Okay, now watch this awesome thing about graphs. I can also check this by doing y equals 3, square root of 2x minus 4 plus 6. So I put the left side into Desmos. I'm going to find it. I got to zoom back out from my previous super zoom in. And it gives me this curve. And then I'm going to graph y equals 3. Okay. Oops. Notice the typo. Do you see how that's not inside? I got to put it outside. And so these two things, they don't hit. You see how those don't intersect? So if things don't intersect, they have no answer. So on the SQL, frequently that is the empty set. And that will work for anything with an equal sign. It'll work for this problem. Okay. All you have to do is solve for y. So even though I did solve for y and I divided, you don't even have to divide. Watch this. If I go in here and I say, I'm going to solve this for y by subtracting everything out. I'm going to leave the 3 on there. 3 equals -x squared, and then minus 6x. So you don't put an equal sign, minus 6x, and then minus 6. It does graph that. Look at that. And then this one's very easy to solve for y. You just subtract x and y. So y equals -x minus 20. And then I zoom so I can see the intersection. And the answer is the x coordinate because it says so. Now be careful of that. This problem asks for the y coordinate. So this answer would actually be -11, -26. Notice what they did here, though. They put this -9 and 6 here because most kids think it's x. Because every answer is x unless they say y. And this is the only time, like on this entire practice test, where they say y, unless they ask for a y-intercept. So the answer is almost always x, but be careful to highlight and know this one is y. Okay, and so there's another one on here that's like the same question, but it asks for x, which is this one, so just as easy. This is a click one, though, and you just find the x coordinates by graphing it. And then we have this problem, which so important that we learn that even though we learned a formula for this, right, we would have to write out the formula, which is a1 over 1 minus r, and then we would have to find a1 by plugging 1 in and getting 2/3, and then we would get 2. You can just type this into Desmos, and that's perfectly fine on the SOL. Obviously, on a final exam or something, you'd have to do it by hand to show work. But, take your vacation when you get one, and this is a vacation. So go to the keyboard, go to function, go to sigma, and just type it in. But there is something very important omitted on Desmos, and that is this. There's no infinity, so use 1,000, and there's no parentheses. So if you put in 2/3 and you raise this to the n, it gives you the right answer sometimes, and sometimes it gives you the wrong answer. So make sure you put this in a parenthesis so it knows where n actually is. I'll show you, it's kind of funny. The first one I show, it doesn't matter, but I'll show you a different example. If I could just type this in correctly, I'll start by putting a parenthesis in. There we go. 2/3, raise that to the n. And in this, you're actually going to use n and not x. That's one of the reasons you can't use other variables for other problems, because Desmos has reserved certain things. The answer is 2. It's super easy. But watch this. Let's say I want to do a problem. Okay, again, it's under keyboard, function, sigma. Let's say I wanted to do a problem like you've seen in class where we want to find from the 45th term to the 51st term. And I put inside of sigma an arithmetic problem, like 3 minus 4n. It doesn't give me an answer. I have to put it in parentheses. Sometimes it does give me the answer and it's wrong. So if I don't put that in parentheses, it will not provide the right answer. So understand that when you use sigma, you have to have a parentheses inside. And when you use the keyboard and put it in, it doesn't automatically put it in there for you, which is, I don't know, kind of frustrating. But now that you have the secret, it's not so hard. All right, so when you ask for a parent function means same graph. And when you look at these graphs, these are the only two that come together like this. So parent function means same shape. So even though these are both rational, they're divergent, where these two, if you graph them, are convergent. You can check that out on Desmos. This problem is interesting because, most teachers, right, use the letters H and K for this, right? So we use an H inside and a K outside, and we use an A on the front, right? And if we use a B there. But the SOL uses whatever letter they want. So they're calling C K. So what we're really looking for is K less than 0, which is where is K negative. And so K negative would make the graph go down, so it's that one. So that's kind of like a thinking question, but it kind of gives you the wrong letters. All right, so then here we have another one where it's just like, which is the graph? So you can just graph these and find the right answer. But keep in mind that the x-intercept, is clearly at 3, so it's got to be a -1. So it's got to be one of those two. That's why I crossed those two out. And then maybe graph it. If you want to know, remember about the horizontal asymptote, it's divide the bottom into the top. So this goes in here 0 times, where this would go in here 1 time. So anyway, it's kind of hard to tell because there's like a 1 and a 0. So I would graph that to make sure you figure out the right answer. Please use Desmos to make sure you get the right answer when you've done some work. So the SOL also has choosing options for this kind of thing, where we start with a graph that looks like this. And you can clearly see that it's reflected over the x-axis. So that's pretty easy to choose. But then if you actually put your key points, remember 0, 0, 1, 1, 2, 4, -1, 1, -2, 4, you can actually see that it's been moved up, right? So you can see that it was translated up. And unfortunately, that's not a lot of help for you in this problem because they all say translated up. Sometimes it'll say up or down, and you can get rid of 2 of them. And so it really comes down to what is this, right? So this thing right here is a stretch in the horizontal direction. So we would come down here and pick a stretch of 2 horizontally because it got too larger. Remember, the factor that it stretches is how much it's stretched, like how much the result of the stretch is. It went from 1 box to 2 boxes. So it's a stretch of 2 in the horizontal direction as opposed to the vertical y-axis. All right, getting close to being done here. So this one is about domain. And remember the way we did domain in class is we did domain by doing a beeping, right? So we came here, nothing, 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 beep. It doesn't stop, so -5 to 2. Some students get really freaked out by this thing, and they come over here and say, maybe it's this one with the and inside. but it doesn't actually stop there. Now, I will tell you this. This function is not continuous. That's one thing to understand. It's not continuous, which is a question that's asked later. Not continuous means no asymptotes in no holes. So that's not the question being asked, but that's what your brain is analyzing, right? This is not continuous, but it does have a domain that covers this entire value. It does have, this is actually called a jump. Or a hole, you could call it a hole. But the break you're looking at is called continuity in math, but the domain is -5 to 2. It's a great question for those who asked me about it in class. Down here, we have an interesting question that involves finding a domain restriction. Which of the following is not in the domain of this problem? It involves a technique that maybe you haven't seen, but we're going to reverse the order of operations, and then we're going to just take a look at a technique that maybe we haven't seen in class, but it'll make sense. All right, so we start at the bottom, and we add the x. But don't add the x that has a y on it, because we're trying to solve for y. You don't want y's on both sides. So we start by adding the x. And if you ever have two y's, the way to get one y is to GCF the y. So if you GCF the y, you take it away from here and here, giving you x plus 1, and then you can divide by the entire quantity, giving you this function. And now it's really easy. What is the domain restriction of this? I set the bottom not equal to 0, and I subtract 1, so x cannot equal -1, and that's what you type in the box. All right, last problem on this one. I did make another video for the rest of it, but I broke it up after this problem. So this one's interesting because it asks about range. So the first thing we want to do is graph it to find the range. So if I come over here, the absolute value, okay, is found right here. So the absolute value is x and then -4. And so when I look at that, I zoom in and my range is above 4. And then I graph each of these, finding the same range. So I'll show you the first one works, right? So x squared plus 2x minus 3. And that one has a range above 4 as well, but then the next one doesn't, and then I'll let you find the other ones. And that reminded me, somehow I skipped it over the absolute value question, so let me find them because they're also in this section. There they are. So let's talk about those. So the absolute value problems, remember, absolute value means that you have two problems, right? So you have to do plus and minus 2, which means the first one you get will be x minus 2 is greater than 2. But then you have a separate one to work on, right, which is -2. So x minus 2, and you have -2, but then you have to flip the inequality around because a negative will change a greater to a less and less to a greater. All right, so then you solve this. Pretty easy to solve. Add 2. X is greater than 4. Okay, and the next one is add 2 to this, and x is less than 0. So you go to 0 and you plug them in, and then you have to check. Right? Is -1 valid in this inequality? The answer is, I put -1 in here, I get 3. 3 is greater than 2, so check. I plug in something in here, I used 1. 1 is false in this inequality, so no. And then here I put in 5, and I got 3 again. 3 is greater than 2, so check. And so I would click and drag these up here. But Desmos is even capable of doing this if you understand the graph it's showing you. So watch this. If I type this in, and I say, hey, Desmos, I have on the left side y equals the absolute value of x minus 2. That gives me a v, just as we saw in the previous problem. And then here I have y is equal to 2. I can't put that inequality in even though I want to, but it's very helpful to understand this. This is really asking me, where is the v, right? So where is this v greater or above this 2, which is a line? So if I look at Desmos, the v is above the line until here, which is 0. Remember, I don't care about the y unless they ask for a y-intercept. So it's above it here, and it's also not above here, so false, and then above it at 4. So this is a two-dimensional version of this one-dimensional graph. So you can see it again here. Less than 0, I am valid above the line, and greater than 4, I'm above the line. That's exactly how you do this problem. Except you would have to subtract 1, divide by -3. When you divide by the -3, the inequality switches, and then you have to switch it back when you do the negative version, and then do the whole checking thing. But you can also check on Desmos. All right, so here we have another absolute value problem, which you have to set equal to 1/2 and have to set equal to -1/2. To solve it by hand, you just multiply through by 8, multiply through by 8, and then you just solve these easier versions. The 8 is the LCD. So if you multiply through by the LCD of 8, you will reduce the problem to a manageable problem where you just add 2 and get 6, and then add 2 and get -2. If you graph it on Desmos, these intersection points are the answer, -2 and 6, -2 and 6, -2 and 6. So 2 graphs on Desmos, find the x-intercept, unless it says y, read the question carefully. 1 graph on Desmos, it's the x-intercept. So always about x, always about x. And then we have this weird question here that is about the quadratic formula. This is just a strange one where they ask, what is the other answer? Well, if you write the quadratic equation down, you notice it has a plus or minus, and they have a minus. All right, and since we're on that topic, there is another question on the quadratic formula right here. Let me find it. And that question is, kind of a little bit of a longer question. And that problem, you just have to sit through and, try to work through it. So if you ever do get a question about the quadratic formula, make sure you're working through the problem and just doing it slowly. All right. Thank you very much. I hope this helped.